This episode is sponsored by 80,000 Hours. 80,000 Hours is a nonprofit that aims to help people have a positive impact with their careers. Head to 80,000hours.org/microcosmos to start planning a career that could potentially help solve one of the world's most pressing problems. From our vantage point, as relatively large organisms, it can be easy to overlook the microcosmos because it is simply too small to see. It floats in front of our eyes at all times, and yet we cannot make out any of the details until we turn to other tools. And then, even when we do turn to those tools, it can be easy to overlook the parts of the microcosmos that seem relatively understated compared to all of the wondrous dramatic events that can take place. After all, if you just come from, say, watching a tardigrade wandering through a maze of moss, you might find something like this a bit underwhelming. There's just some squishy dots floating around, not doing anything particularly noteworthy except for a few brief flashes of movement. The movement is so quick that you might see it and just move on to something else, like when you glimpse a bird flying out of the corner of your eye. It captures your attention for a second, and perhaps it releases it just as quickly. But for today, because we're us, we're going to linger on that moment and let it capture our attention a little longer. Because the organism you're looking at right now is a ciliate called Cyclidium, which is known for its ability to dart straight through the microcosmos like an arrow. It's only a few micrometers in length, but packed in its small body is the ability to detect threats and quickly jump out of their reach. This is not the first time that we've seen a very fast-moving ciliate on this channel. Early on, we watched as bundles of the bell-shaped vorticella extended their long stalks and then rapidly contracted those stalks into tightly packed spirals when other organisms got too close. We've also watched a spirostomum quickly evade unwanted contact, pulling back and shrinking down to get itself out of reach as quickly as possible. We can think of the vorticella and spirostomum as doing something that's more like flinching, a rapid contraction that moves them away from a potential threat, but that doesn't necessarily transport them to a whole new location. It's remarkable and requires both tremendous force and speed, but ciliates like the Cyclidium we were watching earlier, or these Halteria, are performing a very different sort of athleticism, something more like a long jump. Not that they look like they should be setting any records. Halteria are only around 20 microns in length, and most of the time they just kind of spin, like a kid on a teacup ride, with no concept of dizziness. And charmingly, the Halteria is edged in cilia that swirls with it, unfurling as it moves and then wrapping back inward as the organism winds down. Halteria like to feed on bacteria, and they reproduce quickly, so sometimes James, our master of microscopes, will find thousands of them in a single drop, another set of squishy dots that move in and out of focus, sometimes even obscuring the other interesting bits that James is trying to look at. But let's zoom out, past the point where we can see the defined lines of the Halteria's cilia, where it really is just one dot navigating a field of debris, and see if you can keep up with it. Most of the time, it's not really a challenge. It looks like a floater in your vision, a clear blob that just idles away. But then, seemingly out of nowhere, it leaps across the screen and out of view, potentially traveling as far as 100 times its own body length in a single second. That would be like if I, a 6-foot human being, could leap 600 feet in a second. In response to this, you might say something like, okay, yeah, sure, Hank, but you're a human being. Things are different in the microcosmos. And yes, this is true. Things really are different in the microcosmos. In fact, things are a lot more challenging. Organisms like Halteria are living in water, but because of their small size, that water feels like thick molasses. So they have to rely on structures like cilia to help them swim and move quickly. But even then, Most organisms only travel around 10 times their body length in a single second. The fact that Halteria and a select group of other leaping ciliates are able to jump 100 times their body length in that same second is incredible. And we don't know exactly what it is that makes these impressive hops possible, but it does require a lot of energy, so it makes sense that in its off moments, the Halteria prefers to be a little bit more static. And there are a few other members of this elite jumping ciliate group, like the Strombidium you see here leaping around. It is very impressive that James can even keep up with them. And that, of course, is the point, not to avoid James. The ciliates are not aware of him, but the goal of this movement is to help the ciliate be overlooked, to ensure that predators cannot find them. And it works. The slightest brush of a predator's presence sends these ciliates into escape mode. In one experiment, researchers set some rotifers upon a population of Halteria and found that only 12% of them ended up as rotifer food. Another leaping ciliate, called Strobolidium, was even more successful at evading capture, with only 3% of them getting eaten. There is, however, one notable exception to this predator evasion. While Halteria might be able to escape rotifers, they have a dedicated predator called the Actinobelina, which we have talked about before. This tentacled, toxin-loaded ciliate could go after anything it wanted, but for some reason it dines exclusively on Halteria. Why? And how? No clue. Maybe they just got lucky to live in an environment that was rich enough in Halteria that through evolution the Actinobelina was able to learn how to sneak up on their cagey prey. So perhaps it is not possible for them to always be overlooked. Eventually, someone will take a moment to appreciate them. If they are unfortunate, it is the one predator that has managed to find a way around their tricks. But sometimes, it's just us, slowing down just enough to catch a glimpse of something so much faster and so much smaller than we are. Thanks for coming on this journey with us as we explore the unseen world that surrounds us. And thanks again to 80,000 Hours for sponsoring today's episode. 80,000 Hours is a nonprofit that aims to help people have a positive impact with their career. The direction of your career path is a big life decision, and 80,000 Hours has a lot of free resources to help you plan and research what options might be best for you. They've got fantastic free resources, including decision-making tools, a constantly updated job board, and even a podcast where they have in-depth conversations with experts in the world's most pressing problems, and they discuss what you can do to help solve them. In one of their recent episodes, they discussed what's being done on the cutting edge of malaria control and treatment and the state-of-the-art efforts that are going towards trying to create a malaria-free world. 80,000 Hours wants to help you find a career that does good in the world, and all of their provided resources are free. They're a nonprofit, and their only aim is to help you find a fulfilling, high-impact career. Check out our link in the description or go to 80,000hours.org/microcosmos to be sent a free copy of their in-depth career guide and to start learning how you could have a high-impact career. This will also sign you up for their newsletter where they send updates on their research and high-impact job opportunities. All of the names on the screen right now are the names of people who decided that they would be a reason why Journey to the Microcosmos is able to exist and keep making such delightful little bits of content as this one. So if you're looking for somebody to thank, it's these folks right here, and if you're interested in becoming one, you can go to patreon.com/journeytomicro. If you want to see more from our master of microscopes, James Weiss, you can check out Jam and Germs on Instagram, and if you want to see more from us, there's always a subscribe button somewhere nearby.